In this video, I am going to graph 12 functions of tangent or cotangent just to kind of help with getting our hands around these. So let's start with number one here. Number one, so the first thing I look for, just like in sines and cosines, we don't really have a midline, but I look for what would be called a midline. So like if I go through, let me grab a different color that sticks out. My midline goes right through there, okay? So I know the reason I look for that is because I want to make sure I'm not shifting up or down, and that's how I can catch it. Okay, so the period is the next thing I like to look for because it's easier to see. I can see that tangent is going to go between there and there. There's the period going between that. That length looks like, if I stay on those grid lines, it's pi. So my period is pi. There is no shift left or right. You can see, maybe we should have looked over here. But tangent goes through the normal place right in the middle. It doesn't shift left or right or up or down, so I'm going to put none. And amplitude is a little tough to see, but remember it's always halfway between. I'm going to go with a 1 there. So this function is our normal tangent function. The period is pi, that's normal. So this is y equals tangent x. Oh. Hold on one sec. Actually, we messed this up. Let's do the period again. The period is not pi. Each one of these is a pi over 4. So the period is actually pi over 2. So I messed up the grid line here. Let me erase all my markings so we can see it better. From here to here, well, I know there to there, here to here, that's pi over 2. So each tick mark is pi over 4. Tangent takes so tick mark in each direction, so the whole period is pi over 2. Excuse me. Okay, so now, I'm not writing that down yet. Period is always, for tangent or cotangent, is period over b. So that's pi over 2 equals pi over b. We can just use our eyes here. B has to be 2. So I know my tangent function is going to be y equals tangent of 2x. And that's my solution there. Okay, so it's the same idea. Find the midline, look for the period, and then the midline and the period will help with the shifts. So let's take a look at 2. Okay, I see the midline is right through the x-axis again. And then I can see that the tangent, that we're looking probably at tangent here. And the reason I can tell that is it's going through my origin. Cotangent usually does not, has an asymptote. And I can see the period here with, if I just look. I can use that all the way across, or I can use that it's double of that, right? That is pi, so the period is going to be 2 pi. The amplitude is a halfway through on each side, so that is going to be, looks like a 1. The shift, okay, it didn't move up or down because the midline's still right there on the x-axis. And then tangent typically lives between right at the origin here. So you can see that it didn't get moved at all up or down. So this new one, I got to figure out the period because that changed. The period for tangent is typically pi over b. So we got to figure out what is it going to be if it's 2 pi. If I do that and I solve for b, I'm going to get 1/2. So we get y equals, tangent's increasing like it normally is. That's how we tell our negative. If it's decreasing, then it would be negative. Amplitude is 1, so I'm going to get tangent of 1/2 x. So it's dealing with the period got bigger, really, in this one. That's all that happened. The amplitude didn't change. We didn't shift or anything. It just has a bigger period than our normal tangent function. All right, taking a look at 3 here. Okay, my midline again looks like they all go through. I can see the symmetry there. So the midline is there, and then I'm looking for, the asymptotes. Sorry, my iPad is just going crazy. All right, so I have from this line to this line. So I got to figure out how far that goes. Okay, each tick mark, if I look, because here to here was pi over 2, so each tick mark is pi over 4. So it takes 4 of them, so the period is pi. The amplitude happens right halfway, so it looks like that didn't change anything. It's 1. And then you can see that now it is moved over. Normally this, if I use tangent, which I'm going to since we're increasing, it goes through right there, and it's supposed to go through the origin. So it moved over. We can see, I think it moved over left pi over 4. 1 tick mark to the left, right? Because now it's here. It should have been there at the origin, so it moved to the left pi over 4. I know this is tangent because it's increasing. So y equals, it's increasing, amplitude is 1, so I'm going to use tangent. The period is pi, that is normal for that, so I'm not going to change anything here. So I'm going to do tangent of x, and then we need left, so I'm going to do a positive plus pi over 4. That would move my tangent function left pi over 4, and that's all that happened here. Right, looking at 4, I'm going to give you guys plenty of these because these can be pretty difficult. Okay, I can see that the midline hasn't changed, right? Still through the x-axis. Now I need to find my period. Okay, it goes through there and here. Okay, it looks like the period would be, each one of those tick marks again is pi over 4. Again, so the whole period would be a pi. Let me shift it out there. Come on. Hold on, it's being weird. All right, sorry about that. Period is, each tick mark is pi over 4. It does it 4 times for each period. So the period is pi, that didn't change. The amplitude didn't change. You can see 1 in each direction goes up 1. How I would tell if this went up to 2, then the amplitude would be 3. If it was all the way up to 4, then it would be 4. We can just tell really quick there. So the amplitude is 1 again. And then I can see the shift. It moved right pi over 4. The reason I'm picking tangent is because it's increasing. So this is y equals. The period is the same. It should be. Amplitude is the same. So I get tangent. And then inside, I'm going to get x minus pi over 4. So that would be my function. Tangents typically, I feel like we get to do a little bit less work than the sines and cosines. Sorry, it keeps zooming out on me like that. I know it's pretty annoying. It's annoying me. All right, so again, okay, I find that this now, you can see that the midline has moved. Right, there is my midline. That's going to help me with my shifts once I get to that part. So it shifted, looks like it shifted down, and I think it's 1 unit. So it has shifted down 1 unit. All right, and then I identify my asymptotes. I got that one and that one. All right, so the period goes from pi over 2, and you can see it's actually cut in half right here. So that's nice. Each tick mark is pi over 4. I'm going to have 4 across, so the period again is pi. If I go over 1 in each direction from this point, the middle point, I go up again. Does it look like 1? I think so. It's just scaled a bit off. No, that's right. So it goes up and down 1, so the amplitude is 1. And then the shift, okay, it's right here at the origin, so I don't move left or right, right? It's not at the origin, but left and right, it's right on the y-axis. And then we moved down 1. So this is a tangent function. I can tell it's tangent, not cotangent. I could make a cotangent function negative, and that would make it increase. It would flip over, meaning it would look like this then, right? And then I could take my cotangent, put a negative, and if I did that, it would flip to the function that's there. I like to stick with the one that's easier. That is a tangent function. That's what it looks like. The pi is the normal period. Amplitude is its normal amplitude. So I'm going to get tangent of x, and then we're going to put a minus 1 on the outside because I want to move the whole thing down. Okay, I hope these are getting easier for you. Number 6. Okay, so looking here, the midline is right there. I can see the points going through it. And then I have an asymptote going here and there. Okay, so I know this moved up 2, so we're going to write that in. The amplitude, okay, if I go over 1 and up 1, they're keeping these nice and straightforward for us. Those amplitude would be 1 again. The period is going from, well, I can see it here, halfway across. That's pi over 2, so the normal period of pi. And then it shifted up 2. All right, so this function is going to be y equals, I can tell it's tangent because it's increasing. The period hasn't changed, so it's just going to be tangent of x, but I need to shift the whole thing up 2, so I'm going to put a plus 2 right there. Cool. Okay, I hope these are feeling better. A few more. Okay, let's take a look at number 7. This way. Trying to scroll the wrong way. Okay, I can see the quote-unquote midline. It's right there. Right, and then I see this. My asymptotes are there. So it is increasing, so my brain right away is like, oh, tangent. But if you remember, cotangent has those asymptotes, right? 0 to pi and so forth. It's shifted, it's tangent, but shifted over. So I'm gonna make this a cotangent since we haven't really practiced with them. Okay, I can see that this is down 2. The period is pi, that's normal. And we're going to use cotangent. Let's make sure our amplitudes, if I go over 1 and left 1, I go up and down 1, so the amplitude didn't change. So I'm going to make this a cotangent. Cotangent normally would look like this. So to change that, what I'm going to do is put a negative in front of it. The negative in front of it is going to flip it over, making it look like that instead, increasing. I know the period is the same, so I'm just going to put an x inside. I didn't move left or right, so no left or right shift. The period didn't change, and then I put a minus 2. I'm going to go ahead and write the tangent function too. These both are correct answers. I could also do tangent, still increasing, and we moved it over pi over 2, so I'm going to minus pi over 2 inside with a minus 2. That minus 2 would move it over, making, instead of it being right here, the adding minus pi over 2 shifted it over to where it's actually at. Either one of these is a correct answer. Lumen should be able to take both, I hope. If not, that's not a great system. So I'm hoping it will take both. If not, just go ahead and get the practice in on a test. I'm going to give you either one. Okay, number 8. So again, I'm looking for that midline idea. I think it's right here. It looks right. So there's my midline. So I can see that the function moved up 1. I'm also looking for the period. So the period goes from there to there. As I can tell, if I'm looking at it, it is just shifted 1 tick mark, so it's still pi. If I go over 1 and left 1, I'm going up and down 1, so the amplitude is 1. And then I can see that the function's increasing, so again, I would use tangent. So y equals, the amplitude is 1, tangent's increasing. So here's my tan. And then the period's the same, so I'm not going to add anything there. We can also see that this thing should be, if it was a tangent, it would have been, okay, well, here's this. That point should have been right here. So it got moved over. Let me put it in blue. It should have been there. If I want it to be a tangent, right? Not shifted left or right. So what actually happened is the graph got moved left pi over 4. Or you could say the graph moved right 3 pi over 4. Either one will land you in the same spot. So I'm going to do left pi over 4. So if I want it to move left, I do a plus. And then I want the whole thing to move up 1. Right? I could have also done this. X minus 3 pi over 4. And moved it the other direction that much. Right? I could have done that exact same thing. I could have also called it a cotangent function. And we would have had to change our bounds. But again, like I've said in this video, or the last video rather, with the sines and cosines, we can have an infinite number of these graphs. All right, let's take a look at number 9. Okay, number 9. The midline, it looks like it's right on the x-axis. Right, and then it looks like the asymptotes are right here and right there. Okay, so tangent, definitely, it's increasing. It's also going through the origin, so I don't have to do a left or right shift or up and down, so there's no shifts. The period looks like it goes from pi over 2 to 3 over pi. That's a pi, that's normal. The period change, or sorry, the amplitude. I go over 1 halfway through, not 1, but halfway through, and I can see it goes through right here. Same thing here, it goes halfway through. Looks like it's going up 3 in each direction. So my amplitude is 3. There is no shift, so this is going to be nice, easy. The period is our typical, so we get y equals 3 tangent x. All right, so there's that. All right, that's how we deal with the amplitude changing. Okay, let's give, we got 3 more here. Okay, again, I can see the midline. There, I can see the asymptotes, so I'm going to go ahead and just make note of those, but I like to do it with the marker on here so you guys can see what I'm looking at. The amplitude, let's do, I guess, period first. This is definitely sine, tangent. I can see it going through the origin there and going like that. So there is no left or right shift. The midline's in the middle. There are no shifts. The period is pi, so that didn't change. The amplitude, I think, is what we're working on here. I go over halfway in each direction. I can see it goes up. It looks like a half. So the amplitude would be half. Now, I do got to point out, this was like a stretching factor, not an amplitude. But we call it amplitude. It's fine. So I'm going to do y equals 1/2. Tangent, no shifts, no period changes. So we just put the half there. And there we go. Hopefully this is feeling easier for you. 2 more. All right, now I identified the midline. There's my midline. I can see the period here. And I see the 0 to pi period. So I'm going to go with cotangent. My amplitude, I go halfway, and it looks like I go up half. Yeah, so we got 1/2. Then the period is pi, but I'm going to go ahead and do a cotangent and do up. We have an up 1 shift. That's it. I'm going to do cotangent. Cotangent normally looks like that, which would be a negative, or that's why it would be increasing, but we're going to flip it. So I get a y equals, it's going to be a negative 1/2. The half gives me the stretching factor, or quote-unquote amplitude is what we're calling it. I'm going to use cotangent because the negative flips it over. There is no left or right shift, so I put x, and then I got to move this up 1. I could have also used tangent. I could have done 1/2 tangent, and then moved this function pi over 2 over, plus 1. Either one of these would have worked. I would think through both of those. Because either one is correct. It'd be nice to, I think the top one is quicker. I didn't have to think about any kind of left or right shift is where it gets weird. All right, I got one more for you. Okay, identify the midline. Oh, zoomed in on me again. Zoomed out, rather. All right, the midline, it looks like this one's kind of hard to tell. I'm going to go with this for a moment and see how that turns out. Does that look symmetric? Not quite, actually. I think this one may be right here, but flat. That looks better. All right, so we're going to go with these points, I think. Again, like on an assessment, we'll make sure that's not subjective. Right, I have that, and it looks like this is my asymptote. This will help, too. Doing our asymptotes, we'll be able to tell where it's at. So that looks like it's every 4. Does that line up? Yeah. Okay. That makes that much easier. We can see it now. And then the midline, actually, I was off. This is why we do the asymptotes as well. It's got to be directly in the middle. So it's going to be right here, halfway. Halfway. That means that midline actually is down here. There we go. That looks a little more symmetric. It's kind of tough to tell. How I would, zoomed out again. How I was able to tell is I found those asymptotes and then I just cut them in half. Okay. This amplitude, I go halfway and it spits me there. Halfway spits me there. That looks like that's 3. The period goes from 0 to pi, so it's pi. The shift, okay, it depends if we want to do tangent or cotangent. Let's do cotangent. So there is just down 2. That's it. We also have a vertical reflection because cotangent typically looks like that, so I need to flip it over. So when I write my answer, I get y equals negative cotangent. The period, I need to put a 3 out front for the stretching factor or amplitude. Negative 3 cotangent x, and then we're going to move minus 2. I could also have done tangent. I could have done 3 tangent, but I would have had to shift it over pi over 2, and then minus 2 down. Either one of those is a correct answer. Just depends on how you want to look at it. Okay, I hope these help. These can be pretty tough. especially getting your hands around what to look for each time independently for each one.